Hmm. Now it is streaming online.
Yes, sir. Okay, sir. Okay, sir. We will start now. Good evening to everyone assembled here. We are assembled here for the online international workshop on statistics using jamovi, organized by Akuman Foundation and Seva Academy. Here we have our resource person, Dr. Paraksha sir. Paraksha sir is from Gujarat. Sir is presently working as an associate professor of statistics at HL College, Ahmedabad. Sir has more than 20 years of experience. Sir has acquired analytical skills through courses from renowned institutes like CMC Vellore, IIT Kharagpur, IIT Hyderabad, Duke University, USA, and IBM. Author of more than 15 books, some of which in Tata McGraw. Tata Mag, I can't pronounce it, sorry. In editorial board of number of research journals. Sir has more than 25 research articles in his name published in national and international journals. Sir has been invited as speaker and has been acted as a resource person in many renowned institutions of national and international repute. He also provides analytical consulting services to various industries, sharing his statistics expertise by special lectures for CA, CMA, MBA, ACCA students and students of other professional courses. So with rich profile, Sir is here for us to uh, have a program on statistics using jamovi. I kindly welcome you, sir, and I request you to handle the session. Thank you, sir.
Thank you. Thank you for the wonderful introduction.
Thank you, sir.
And it is always said that a good beginning is half done. So it's nice to have participants coming from the varied domain and from the varied geographical locations. So compliments to you for organizing such kind of programs for the participants from the different domain, so that right statistics and right data analytics tool reaches to the practitioner or reaches to the researchers across domain. So compliments to you for organizing such kind of programs, and that too at a very nominal rate for the participants. So good
Thank you,
evening to
sir.
all. Good evening to all. Just write down hi to all, hi in the chat box, so that I can know that you are live and we can have a very interactive session. Yeah, I've already got it from Dr. Bharti, Dr. Natarajan, yeah, Dr. Angana, Dr. Augustine, Jenny, and all. Dr. Lata, Mohandas, Dr. Pauline, Mohandos. Good. Okay, Srija, Kiran, that's great. So, though it is an online, we will see to it that it becomes more interactive session. It is not a one way. Thank you, Ekta. Niruna, that's great. So, what I will do is we will go into the details of what is statistics, what is how it is applicable in a different domain, how it will be useful for you in your particular domain, and we'll make it more interactive. So I'll be constantly checking the chat bot, and I'll be asking you the questions. You have to chat over there, you have to give the answers for that. And your questions also I'll be answering on the chat box, or it will be a live session for it. So though it is an online, it will be very, very interactive. That I promise you. Secondly, we promise that the time that you have invested, that time you will be planning to invest for whole this program, it will be worthwhile. After the program, I ensure you that you will be able to analyze your data with a very important and a simple online free tool, which is Jamovi. With a sound statistical concepts, because that is very, very important and missing. Many are doing data analysis, might be doing data analysis, but the sound knowledge of statistics is missing. And as ma'am has introduced, I am rather into board of many research journals. Unfortunately, a lot of research papers comes to us with the wrong statistics. So purpose of having such kind of programs, purpose of conducting such kind of programs for individuals for different domain is so that right statistics reaches to each and every individuals and the practitioners across India and across globe. So that is why we are conducting such kind of programs on regular basis, which one or the other tool. So we conduct the program for data analysis using jamovi, using SPSS, using R programming, using it may be a stat, it may be using Python and all. Tool is secondary. Concepts are very important. When to apply a particular statistical technique, when to apply a particular machine learning technique, to get that concept is very important. Once that is clear, the other part, which tool you are using, becomes secondary, because the tools, the softwares, the programming language are there, and it will make life easy for you. So our more focus for the whole session will be to give you the concept of the techniques that we'll be going to use, and give you hands-on experience of how to do the data analysis using Jamovi. What is Jamovi? Why it is easy? Why we have to focus more on Jamovi than other softwares? All that has been taken care of, and it will be again taken care tomorrow by Raju sir. Because Jamovi is an open source software. It is a menu-driven open source software. Otherwise, if you use SPSS or any other tool, it is a paid version of it. A lot of money has to be invested for it, and no need to do if open source are available. And that is why the world, the companies are moving towards open source software like Jamovi, like R programming, like Python, and so on. Okay, with this background, we'll begin with a very, very important aspect about the data analysis, and that is the world. I would say the world is saying that now oil is no more oil is no more a valuable resource for us. 10, 15 years back, if you all recollect it, we were saying that oil is a gold. And that is how the Gulf countries have flourished. Because the amount of oil that they have exploded from the earth and the world is using, they have minted money like anything. So oil was considered to be the gold in before 10, 15 years. Now, according to the very famous, I would say, very famous magazines and all the journals and all, it is said that oil is no more a valuable resource for us. Because you see now the world is moving towards renewable energy, solar energy, and all such kind of resources they are moving towards. Oil is no more a valuable resource. Then what is a valuable resource for us? Data. Data is a valuable resource for us. And that is why many industry experts says that world is moving towards data economy. Today, data, the companies having huge amount of data are considered to be the market leaders. Take an example of Google. Majority of the services provided by Google are free. Still, it is the topmost company in the world. You take an example of Facebook and all. Okay. Again, what they are doing it, they are providing services free. Instagram is free, Facebook is free. Still, they are making money, minting money like anything, because they are on the top of the heap of the data. So today, data is considered to be the new oil. Today, the data is considered to be the new oil The amount of the data that a company possesses or an individual possesses is considered to be more valuable. And that is the reason that data is considered as a new oil for us. But now, the same way, as you can see, when the oil is extracted from the sea or from the earth, it is of no value. It is a raw black oil. If you see, it is called a crude oil. Crude oil itself is no application. Crude oil itself cannot be utilized directly. Same way, raw data is of no use. You cannot utilize any kind of applications of raw data. You need, as you can see, oil needs to be refined before we use it. Before you use it like diesel or a petrol or gasoline and so on, like a petroleum jelly and so on. Same way, raw data, unless and until you refine it, is it of no use. And if you want to refine that data, you need statistics. So, what is the statistics? It is a tool, it is a technique to convert your raw data into meaningful information. It is a data analysis technique which converts your raw data into a meaningful information from which you can take decisions which are for the businesses. It is to increase your profit, to increase your revenue, to decrease your cost. So ultimately, you are improving the bottom line. For an individual, it is to improve the productivity, to increase our efficiency. That is where data analysis and statistics comes into the picture. So today we'll be talking more about statistics and its application. So one thing is clear, that data is a new oil. Everyone is clear with that. And only pure raw data is of no use, like raw crude oil. It needs to be refined. And so we need statistics. So we need data analysis. Okay, fine. Then the next question is come, then what is data? Okay, what is data? Just let me know, out of the options that I give you, write down in the chat box, out of that, what is the data? This is the data. This is the data I've taken from the government website, area, production, that is crop, area, production, productivity, and so on. This is some text about the Chandrayaan 3. This is the satellite image of the crop or maybe the different crops in India. This is the audio and this is a video. Okay. So these are options. This is number one. This is number two. Image is number three. Audio is number four. Video is number five. Now, fast on the chat box, just write down out of that which is data. Okay. Dr. Natarajan. Everything is data. Okay. Miruna. Okay. Shubhasri. Okay. Kanchana. 1, 2, 3, 4, 5. Fast. Yes, that's good. Everything is data. Dr. Gilata. Fine. Anyone else? Yeah. Okay. Kiran. All is data. That's good. Collection of facts. Okay. Priya. Dr. Angana. All are data. That's good. Sure. So that means all are in same lines, that everything is data, sir. Okay, Jenny. Great. I'm happy that all of this are data and that you are very clear with. And to be very honest, in the other workshops that normally I take, very few are able to say that all are data. Normally, they feel that only numbers are data. But that was older part, 5, 10 years back. That only numbers was considered as data. Okay, Pushpa, Devi, that's great. Right? Only numbers are no longer considered to be as a data. I'll explain why and how. This is a text. Numbers are data that everyone knows, so this is out of question. This is text. Now, text is considered to be again an important data for us, and there is a technique called sentiment analysis. Or it is also called text analytics. which is now been used in social sciences and psychology in a very big way. Whatever, whatever we write down on the social sites, maybe Instagram, whatever we upload, whatever we write down on Facebook, whatever comments we give on YouTube, okay, all that are considered to be the data. I'll give you an example for it. YouTube is earning from the post that you, or from the write up that you post on Facebook. Say, for example, there is an individual, every morning he writes down one sentence: what a wonderful morning. Oh, what a beautiful flower it has been in my garden. Okay, what a cool breeze. Some kind of, every day he's writing down some or the other comments on the Facebook. Facebook captures all that write ups, and they perceive the personality of that individual. Based on the write up that is written on the Facebook, they perceive that this is a positive minded person who roams about in a garden. He is enjoying the fresh air. So the personality of that person is perceived based on the sentiment analysis, based on the comments that you have done, based on the post that you have written on. Based on that, your data is sold. So now that person on Facebook will be shown that kind of advertisement, like going for a trekking or an outing or creativity. Such kind of advertisement is shown to him because that shows that the personality of that person, based on the sentiment analysis and the text analytics, it is perceived that it is a very positive minded person. He loves roaming about in a garden. He is very close to nature. Accordingly, it is shown to him. Same way, the other way around, if a person always comments a negative thing, oh, oh, again it rained. Now it will be difficult for me to go to the college or to go to the office. A scorching hit, suppose you're saying, okay, it is a windy morning. If that kind of comments are there, then again the personality has been perceived that it is a negative minded person. And so the advertisement of self help books, counseling sessions, psychology seminars, that kind of advertisement is shown for. So your data is sold. Another example, if I give in the terms of politics, as now we're having a Lok Sabha election, sentiment analysis is used in a very big way in politics also. All the statements given by the politicians, majorly, all the speeches that are given into the sabhas that they go for across India, there is a sentiment analysis done on all the script. All this is scripted. Okay, all it is planned. So they go for sentiment analysis and their script is given a score. That script is given a score. And they find out how many positive words are there in the script, how many negative words are there in the script, how many neutral words are there in the script. And based on that, they identify what will be the impact of this script on the audience. This is sentiment analysis. I'll give you an example of my own research paper. What we did was, for all the Hollywood movies, I did it this probably 3 years back. In that year, all the Hollywood movies that were released, the trailer was released on YouTube. We know that the movie trailer are released on the YouTube. For Indian scenario, the songs are also released on the YouTube, and people comment on that. People may comment that it is the same old story, it is same action scenes, it is a romantic movie, or I'm eager to see the movie, or it's okay, oh no, again it is the same stereotype movie. That kind of comments are written. Okay, that kind of comments are written. We took up all that comments from API of YouTube. We analyze that and we identify how many were positive, how many were negative comments, how many were neutral comments. Plus, we took the actors in that movie. We took the information of the director, the producer, that is the production house, what was the making charge, all that information we collected, and based on that, we predicted the box office collection. That paper is already published in a very good research journal. what would be the box office collection based on the sentiment. This is the sentiment. Whatever the people write about the movie or a trailer, it is a sentiment. So based on that sentiment analysis, we could predict what would be the box office collection. So this is just an example of text analytics. Okay, this is data. That is the number analysis. This is image. Image is also considered to be a very important data for us, because now a lot of satellite has been, if I talk about that example, a lot of satellites have been given into the has been sent to the space. Satellite is constantly capturing images per second. All that images are sent back to the earth. There is a processor which do image processing, and based on that the actions are taken. Say for example, this is the actual image I've taken of satellite for the yield of crop. These are different crops. Different color shows the different crops and the level at which it has grown. Okay, that on that basis, prediction is made on what will be the yield of rice this year. What will be the yield of rice in this year? In which area of India, how much yield will be generated, how much yield will get it for rice, that can be estimated or that can be predicted using this image. So there is no person to just see only this and based on that he evaluates. No. Spatially, this data is been splitted into pixel by pixel. Small pixels, they are divided into small pixels, and based on that, that data analysis is done, and based on that, the prediction, the estimation, and the analysis is done. So it is in a huge way data. Pictures are considered to be the data. Audios are also considered to be the data. Videos are also considered to be the data. Videos are nowadays used in again a big numbers in sports franchising. Sports franchise. If we talk about IPL or any soccer league or any kabaddi league and so on, every team is having a video analytics, video analyst. What is his role? Frame by frame, every second, frame by frame, the game is disintegrated. The frame is divided, the game is divided frame by frame. On that basis, they decide what is the strength of the batsman, what is the weakness of a batsman, what is the strength of the bowler, when he gets out, by which type of ball he gets out, after particular score, how will he change his game. Frame by frame analysis is done, and based on that, the the coach guides the bowler to bowl in a particular direction, bowl in a particular, I would say, segment of the pitch, and same way the batsman also realizes that. This is where video analytics comes into the picture. This is one example. I'm talking about the sports. Same way in interviews also, when they take physical interviews also, the body posture, the body movement, the hand-eye movement, everything is captured, and based on that, the candidate's confidence, the candidate's truthfulness, the candidate's honesty is also being measured, which otherwise was measured just by observation, and that was observed by the interviewer, and there were chances of biasness. Now, because of video analytics, that biasness, subjectivity has been removed and authentic results have been produced. And it was used in a very big way during interviews, online interviews during COVID. So during COVID, there were a lot of online interviews were done, and there was no physical meeting. Still, a right candidate could be selected based on video analytics. So you can see now world is moving towards all this kind of data in a very big way. Okay, clear? Any questions till now? नहीं. ठीक है. Dr. Ananga, no question. Jenny, Priya, that's great. Sure. So bottom line is Up till now, whatever we have discussed is there are data which is numbers, it can be text, it can be image, it can be audio, it can be video, and all this. Even emojis are a data. Just I'll extend to that. Whatever type of emojis we send on WhatsApp or we send it on Instagram, that is also a data. Whether you are giving a smiley, whether you are giving a crying face, whether you are giving the this kind of things and all these are also considered as a data. So what is the data? Data can be numbers, it can be text, it can be image, it can be audio, it can be video, or it can be even emojis. I hope we are in the same line now. Okay? Everything is clear that all these are considered with data. Now, we know data can be classified as a quantitative data and a qualitative data. That everyone knows. Yeah. What is a quantitative data? Which can be quantified numerically. Okay. The characteristics of that particular individual or that particular item or observation can be expressed numerically, like height, weight, income, yield of crop, expenses, GDP. All that can be quantified. So they are called quantitative data. So the characteristics which can be quantified in numbers, they are called quantitative data. I hope it is clear. Good. If I talk about qualitative, which cannot be expressed in numbers, which cannot be expressed numerically, they are called quantitative, qualitative data, like eye color. Now we may have an individual with brown eyes, with black eyes, with gray eyes, and so on, with blue eyes. So here I'm not able to give a number to this. I have come just classifying it that it can be brown or black or gray or blue and so on. Or even the color of the clothes that you have worn. Say there are 48 participants right now. Okay, 48 participants. I can just group it under the color of the clothes that you have worn. I can group it according to the gender. I can group it according to the individuals having specs and without have specs. Okay, then that is called qualitative data. Gender, religion, okay, all that, nothing else, but it is a qualitative data. So that I think everyone knows. Next and the most important, so everyone pay attention here. This is the most important aspect for data analysis, and unfortunately, this is the most ignored segment also. This is the most important yet ignored segment. I want everyone to pay attention over here. The levels of measurement. We know it is qualitative, quantitative data, that's fine. We need to go deeper, dig down deeper to get a proper understanding about the data. And that is where it comes the level of measurement. So basically, there are two levels of measurement broadly. Broadly, we can say there are two, categorical and the other is numerical. In other words, you can say, categorical means qualitative and numeric means quantitative. Make sense? Okay. Category. So we are categorizing it. We are grouping it. We are classifying it. So it is a qualitative data. And if we have numbers, it is called a numerical data or it is also called a scale data, depending on the software that you are using it. But ultimately it is a quantitative. In the case of categorical, again it can be classified into two, nominal and ordinal. In numeric, it can be classified into two, interval and ratio. So now you can say there are four levels of measurement. Four levels. The lowest level of measurement is nominal. Only certain characteristics has been observed over here, taken into consideration over here. Then it comes ordinal. Then it comes interval. And then it comes ratio. So these are the four levels of measurement in this hierarchy. When I say hierarchy, means the lowest is nominal. In the steps, lowest is nominal. Little more information is covered in ordinal. More information is covered in interval. And the highest information is covered in ratio. So you can say ratio is the highest level of measurement. Make sense? Okay. We go deeper into this now. When I say nominal, nominal level of measurements means we are just grouping it. We are just classifying it like gender. Say we classify as male, female, and third gender. I'm only classifying it. Can I quantify it? No. Can I say males are better than females or females are better than males? No. I talk about eye color, blue, black, gray, and so on. Again, I'm grouping. I'm not able to order, I'm not able to give the numbers to this. These are called nominal. These are called nominal level of measurement. Where what we do, we only classify. Here only it is classified or grouped. Then it is called a nominal level of measurement. Examples, a lot of examples we have already taken. Participants with specs, without specs, color of the clothes, color of the eye, gender, religion, the geographical location that you come from, all that is nothing else but a nominal level of measurement. Bottom line, only grouping, only classification. Next step comes ordinal. Catch the word order. Order means rank. Ordinal. So after grouping, after classifying, if we are able to rank them, if we are able to order them, then it is called ordinal level of measurement. Say for example, education. We can say it is primary, secondary, higher secondary, graduation, post graduation, PhD, and so on. So here education is grouped. We have just classified. Can I rank them? Can I order them? Yes. Primary is lower, then it will be secondary, then it will be higher secondary, then it will be graduate, then it will be postgraduate, then it will be PhD, and so on. So after classification, if you are able to rank them, if you are able to order them, then it is called ordinal level of measurement. Chalo, fatafat. In the chat box, write down any other example of ordinal. I want everyone to be a part of this program, right? Yeah, Pushpa, yeah. Okay, income, fine. Anyone else? Devi, Jenny, daughter Ranga. Okay, education level I have written. Subhashri, age. Okay. Anyone else? Designation. Makes sense. Okay. Physical activity level. Farmers, how class ranks. Okay. Lower, medium, higher, and perfect, Dr. Angna. Latha, yeah, weather also we can say it is a um, high temperature, low temperature. Performance level good. Occupations good. Occupation becomes slightly difficult, Natarajan sir. Grade point average, Kanchanaji, perfect. Performance of athletes, high performance, low performance, medium performance. Okay. Level of education, Dr. Bharti. Viewership, Rupinder. Uh, Low, high, that way we can group it. Okay. Fine. So this means Not all, but I would say many of you have understood it perfectly. If I say age, the example that many of you have given, my age is 57. Another person's can be 48. Someone can be 60. Someone may be 15. Say, for example, this is the case. These are numbers. These are numbers. If they are numbers, they are not a categorical variable. It is a numeric part. If same way with the income may be 2,75,000, maybe 1,58,000. So they are again numbers. But yeah, if you say income group, age group, then it's fine. Then it becomes ordinal. So in short, what is ordinal? It can be classified in group and then one step ahead. So first step is classified in group, which is there in nominal also. Next step, it can be ranked or ordered. Okay. It can be in your job, it is junior clerk, then it can be senior clerk, then manager, senior manager, president, and so on. So that is also nothing else but this. The level of satisfaction. Now, this is very, very confusing, and many of you might be using in your research or might be in the application part. Likert scale 1 to 5, 1 to 10, Likert scale. We feel it is a number 1, 2, 3, 4, 5. They are not numbers actually. They have been classified as numbers. 1 means low and 5 means high. So Likert scale is also an ordinal level of measurement. Finishing point, first position, second position, third position, that is also ordinal. But if I say the time taken to reach, suppose they are sprinters, the time taken to reach the finishing point, that is numeric. But if I say the position, whether you are first, second, or third, again it comes to ordinal. The level of pain, okay, or we can say military positions. We have officer, lower grade. Then it comes to lieutenant, then captain, then major, then colonel, and so on. So colonel is the highest position. Then it is lower is major, then lower is captain, then lieutenant, then officer, and so on. So you can see after grouping, if we are able to rank them or order them, then it is called ordinal level of measurement. You all agree? Mileage of vehicles, again, you can say mileage of vehicles is nothing else, but it will be in terms of numbers. That is a numeric. Viewership, numeric. IQ level, again, IQ level, how you are measuring it, 109, 101, 95, 75, somewhat of that kind, 120. So that is again a number. Mileage is a number. Age is a numeric one. Dr. Bharti, age is numeric. Okay, because we know that age is 37 years, 48 years, 51 years, 75 years, 15 years. They are numbers. Okay, if I say income group, lower income group, middle income group, higher income group, then they are becoming ordinal. Age group also. The age, if I classify as less than 18 years, 18 to 30 years, 30 to 50 years, and above 50 years. This is again ordinal. But if I only use 18, 75, 28, 37, 38, 35, then it comes to numeric. Getting the difference? Yeah. Rupendra ji, if you do it in this way, you are right. Infant, children, teenage, adult. So if you measure in terms of age as years or age as months, it becomes numeric. Getting it? So otherwise, it comes to the age. Okay, Dr. Bhaji. So age is both. It depends on how you are measuring it. If I say age level or age group, then you can say it is ordinal. But as a age in years, age in months, it is numeric. Good. Next part it comes to is a interval level of measurement. This is theoretical. In practice, when you use any software, basically we'll go for three levels of measurement. Only three. When you go for softwares, one, nominal; second, ordinal; and third is numeric. In softwares, they don't classify further this two into interval and ratio. They don't classify. But theoretically, yeah, they are different. So I'll take some time in giving you the difference between interval and ratio. In interval, let me confuse you by saying a statement: zero is not actual zero. Zero is not actual zero. That is interval. Okay, I'll discuss it later on. Another part, in interval, all these operations are true. Addition, subtraction is true, but multiplication and division is not true. This is not. Okay, let me take that part also. If I take nominal, the operations that will be used is equal to and not equal. Means whether a person, whether a participant is a male or not a male. So it will be equal to, not equal to. A person is having a blue eyes or it is not having a blue eyes. A person is wearing a white cloth, not wearing a white cloth, or it is wearing a white cloth. So always equal to and not equal to. When we talk about ordinal, equal to, not equal to will be applicable. Also, what will be applicable, because now we are ordering it, we are ranking it. So we can get it less than or equal to, greater than or equal to, and so on. Like we can say low income, middle income group, and high income group. So we can say low is less, middle is less than high, and so on. So we can give this kind of sign also, less than or greater than or. In the case of interval, we are going one step further. We can go for equal to, we can go for not equal to, fine. We can go for greater than or all, this is also fine. And the next part comes to plus or minus. We can go one step higher, that is plus or minus. Now understand this part. When I say zero is not zero, okay, zero is not zero. If I talk about that part, if I say zero income, that means no income. Absence of that characteristics means absence of income. If I say zero attendance, means actually no attendance, right? But if I say zero temperature, 0 degrees centigrade, does it mean there is no temperature? Does it mean there is no temperature? There is a temperature, but that temperature has been labeled as 0 degrees centigrade. So here zero does not mean zero. Zero is not actual zero, it is a symbol that is given to you. So whenever your level of measurement is such that zero is not actual zero, it comes to interval. You can also say set score. Even longitude, latitude. This is a globe. This is, say, zero latitude. Means equator. Does it mean there is no latitude? But it has been numbered as zero. This has been numbered as zero. So there is a latitude, but that has been given a number as zero. Okay, let me give you one more example for this. This is a size, dress size for girls. If I say the dress size for girl is 8, 8 is the size of the dress. It means it includes 32 bust, 24 waist, and 35 hips. If I say dress size is 10, that means it is 34, 26, 37. Now, if you observe it carefully, from 8 to 10, I have added 2. I have added. Then from burst also 2 is added. Waist also 2 is added. Hips also 2 is added. So addition and subtraction holds true. But if I go with this way, if I go from 8 to 16, this is 8 to 16, means I've multiplied by 2. 8 to 16, if I take it in that reference that I've multiplied by 2, here you can see it is not 32 into 2. It is not 24 into 2. It is not 35 into 2. So multiplication and division does not hold true over here in interval. So these are the two things that you have to remember for interval. 0 is not actual 0. And second, addition and subtraction holds true, but multiplication division does not hold true. This is called interval level of measurement. Last is ratio. It includes all characteristics of the data. And where 0 is actual 0, the operations are all mathematical operations can be employed on that. Plus, minus, multiply, division, greater than, less than, not equal to, all. So the example can be height, weight, yield of crop, income, expenses, consumption, electricity bill, mileage, all that can be taken as ratio. I hope it is clear. Okay, let me sum up this thing. Then we'll move further. Then I'll ask you to answer it. Huh? I'll ask you to answer. What is that? It starts with the bottom part. What is that? What is the bottom part? Yeah, in the chat box. What is bottom part? Nominal. What it comes after that? Ordinal. What it comes after that? Interval. And then it is ratio. So let me do it again because then I'm asking you to answer it. Nominal means only classification, nothing else. Ordinal, we classify and then we are able to rank, then we are able to order. This two will combine, all other are numeric. So now when I ask you in the chatbot that you have to write down, okay, I'll read out the names also. Those who are not active, I'll read out the names. I want everyone to be over here because you have invested your time. Money, I consider it secondary. You have invested your time, you should get your return. So for that, I want you to be 100% over here. Clear? Good. So what you are classifying now? Data can be qualitative, it can be quantitative. In qualitative, it can be nominal and ordinal. In quantitative, it will be interval and ratio. Make sense? Okay, now this is the data. Order. This is my first variable, whether it is online or offline. The brand of the bicycle that we have purchased, like in India, we say it is a BSA, SLR, and so on. There are different bikes. Here it is Solex cycle, OHM cycle. These are the brand of the cycle. Third variable is product line, whether it is a standard bicycle or it is for the mountain bicycle and so on. Fourth is a product size, small, medium, large, and so on. It is a small cycle, medium size cycle, or a bigger cycle. And lastly, it is the price of that bicycle. These are the five. Okay, these are five variables. This is ID. ID is not a variable. It is just a serial number kind of. Now I'll ask you, and you have to write down in the chat box. I want everyone to do it fast because we are running short of time. There are lot many things to be done. If I ask you price of the cycle, write down in the chat box what it will be. I'm writing down what I'm expecting it. Either it can be nominal, it can be ordinal, or it can be numeric. I want one from this three. Come on, fast. Okay, that's great. Fast, fast. Okay, Shubhas, you are saying nominal, you mean numeric, or nominal, numeric, nominal, numeric, 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 numeric. Okay, great. Okay, Sridevi, Lata, Oppo, it is A5 written somewhere. Okay, Dr. Pauline, Dr. Ananga, numeric, numeric. Okay, I get one nominal answer in between. Subhashri says is nominal. Ratio, I don't want ratio. Dr. Bhati, you're right, but I just don't want in that detail. But you're on the right track. Okay, Dr. Augustine, Jenny. Okay, Dr. Bhati, now you have changed. That's good. Yoga, Priya, Bhagyalakshmi, numeric, Sridevi. Great. Okay, Manju, that's fine. Yeah, it is very true. It is a numeric. Almost all of you are right. Why it is a numeric? This price is numbers. This price is nothing else but a number. And as it is a number, we say it is a numeric level of measurement. You all are with me now? It is a numeric. Come on, fast. Second, product size. Low, it is small, medium, and large. Make it fast. Product size. Okay, Manpati, Jenny, that's great. Kamalishri, are fast, very fast. Then all are right. That's great. Okay, Baby Jyots, Dr. Pauline, Kanchana, again Oppo something, Rupinder, Ordinal, Jilata, Dr. Ananga, and Priya, Mr. Augustine, Adeline, Joy, Pushpa, Subhashri, Mohandos, Bhagyalakshmi, Sridevi, Dr. Bharti. Great, great, very happy. It is an ordinal. Because what you are doing after classifying it, you are saying it is small, medium, and large. So we are in same line. Great. Last, brand of the bicycle. Brand. Sir, on the chat board. Fast. Okay, Dr. Chilada, fine. It is nominal. Dr. Pauline said it is nominal. Kanchana, Oppo, Mondas, Kamasri, Bhagyalakshmi, Sridevi. Oh, Adeline nominal. Pushpa, he says nominal. Rupinderji, Jenny. That's great, Sridevi. This is nominal. That's great. Super. So this means it is a nominal level of measurement. Why it is nominal? Leela ma'am, I should appreciate the wonderful crowd here. They are picking up very fast. So that much they are picking up or they have that kind of knowledge. That's great. So it is a nominal level of measurement. So now it is very clear that we all are on the same page. What is nominal, ordinal, and numeric? Okay, makes sense? Now the question arises, why so much emphasis is given on level of measurement? हाँ, ये question तो आया होगा ना? You might be having that kind of question. Why so much time is given on this much level of measurement? The reason. Now let us go with that reason. Okay, Dr. Anga, Dr. Augustine, Dr. Bharti, Mangapati, Mandapati, and so on. Okay, that's all. That's great. So I'll answer this question that why so much stress on this? The reason is number one, to decide the summary statistics, right summary statistics. If you want to decide the right summary statistics like mean, median, and mode, like standard deviation, dispersion, and all, we need to know the level of measurement. You'll be amazed, you'll be surprised when we go into that detail. Appropriately present your data. We all might be using graphs, pie chart, bar chart, histogram, and all. The question arises when to use which type of graph. When to use which type of graph is a major problem. I'll go into that detail also. And lastly, to decide proper statistical test. When to use Z test, when to use ZT test, when to use ANOVA, when to use chi-square test. All that depends on the level of measurement. You can see up till now, we were considering quite a lot of things that it is obvious. When to use mean? So whenever we say average is asked, we have to go for mean. It's not true. All this depends on the level of measurement. The data that you have captured, the data, the variable that you have taken, the factor that you have taken will decide which graph to draw, which summary statistics to use, which test to use. All that will be decided by the level of measurement. So now we'll dig dive into this. Okay, so this is some myths that we are having it. I'll clarify that myths. This I'm skipping right now. Okay. You all know about central tendency? Okay. What is central tendency? Central tendency is nothing else but a number, a measure which represents your whole data into single value. That means if this is your data, these are the observations. Okay, these are the observations. Then central tendency means a number which tries to be at the center of the data. It is not necessarily exactly at the center of the data, but it has a tendency to be at the center of the data. That is why the word is used tendency, central tendency. So a measure, a number which tries to be at the center of the data is called central tendency. It is called central tendency. And which are the central tendencies? We all know mean, median, mode. And if I ask you a question, when to use mean, when to use mode, when to use median, then it is a big question mark. So that is the correct knowledge that we want to gain by this workshop. So coming back to this, central tendency is nothing else but to summarize the data into single value. And when we summarize into single value, the next question it comes, the measures of dispersion. So what is measure of dispersion? How much the observations are far or close to the central value. What is the distance between the observation and the central value? That measure is called dispersion. So the central tendency is what? A value which measures the central, which remains, it tries to be at the center. But how much the observations are close or away from the central value, that is measured by dispersion. And you might have heard about range, you might have heard about quartile deviation, you might have heard about variance, you might have heard about standard deviation. These all are dispersion. But again, the question, when to use range, when to use quartile deviation, it is a big question mark. So now I'll clarify all that aspect. So now you know central tendency, there is mean, median, and mode. How mean is calculated? We all know. Total upon number of observations. Everyone knows? Yeah, I'm sure everyone knows. Second, median. Median means the middlemost value. It is a middlemost value of the data after arranging in increasing or decreasing order. That is a median. I'm talking in very layman language. Mode, value which is repeated maximum number of times. A value which repeats maximum number of time is a mode. So this you all know. So I'm skipping that. Next it comes to dispersion. As I said, dispersion means how much the observations are close or away from the central value. We know range. Range means what? Highest minus lowest. That everyone knows? Yeah, I'm not sure you are knowing that. What is interquartile range? Academically, we always use quartile deviation. But industry person don't use quartile deviation. In industry, it is always used as interquartile range. And what is interquartile range? If you arrange your observation in increasing order and plot Q1, Q2, and Q3, First quartile, second quartile, and third quartile. Okay. What is that? 25% each. So our data is divided into 4 parts, 25%. So Q1, Q2, Q3. Okay. Distance between Q1 and Q3. This is called interquartile range. Means it is Q3 minus Q1. That is called interquartile range. And lastly, it comes to variance. Variance means sigma x minus x bar whole square upon. And if you take a square root of this, it is called standard deviation. I'm sure you all are knowing, but just I'm helping you to recollect it. So this all know, everyone knows. I'm sure, yeah? Okay. So range, interquartile range, variance, and standard deviation. Next, it comes to positively skewed, negatively skewed, or zero skewed. That means if I plot my data, and I get a perfect bell shape. Bell shape means this area and this area are exactly identical. Then it is called symmetric data or a normal data or zero skewness, no skewness. But if your data is positively skewed, mm, the tail is elongated towards right. It will never touch zero, but the tail is elongated towards right. It is called positively skewed. If the tail is elongated towards left, then it is called negatively skewed. So this is positively skewed, this is negatively. Let me give a funny example for this. Okay, I'm sure you are not, this is not applicable to you. You're very, very attentive and you're very, very interactive and participative. But let me take a general example for this. A funny example. Take an example of attention span or attention level, focus level. Generally, what happens, not for you, generally, what happens that when the program starts, your attention level is very high. 10 minutes, 15 minutes, the attention level is high. 30 minutes, say max, it is at high. Then the attention level goes down. It will never touch zero. You know what the speaker is saying, you know what sir is saying, but your attention span goes on decreasing. This is an example of positively skewed display. If you take an example of people coming to the theater for movie, say the show time is 9 o'clock. Just start observing the number of individuals coming from 8 o'clock. Just start observing. Initially, there will be very less number of persons. 8 o'clock, 8:10, 8:15, 8:20, 8:30, and then it picks up. At 9 o'clock, it will be at peak. This is negatively skewed. Make sense? Positively, negatively? Okay. This was just to give you a detail about it. Right now, we don't need it. Right now, you only understand whether it is a perfectly bell shape or it is not bell shape. Means this is skewed data, this both, and these are not skewed or normal data or symmetric. Just understand that much. Now we'll go with which summary statistics to use. So this is my second important slide for the day. So focus on this now. Okay. Level of measurement. Which are the level of measurement? Now we all know. Nominal, ordinal, and numeric. I'll classify into three only. So if your data is nominal, then you have to go for compulsory mode as your central tendency. And you cannot use any dispersion over here. This means, suppose you have collected the data of gender. Say there are participants or say employee. Say we are having 100 employees and we have collected the data for gender, male, female, male, male, female, and so on. I want to find out average gender. Yeah, I can. So here, gender is a nominal level of, and if I want to find out average of gender, compulsory I have to go for mode. Compulsory mode. Why? Because which is maximum frequently repeating. If males are more, then the average is male. If females are more, then the average is female. This is the right way to calculate the level of measure, to calculate the average. That is the central tendency. Unfortunately, you will see many books in which they give the answer as 1.2 males, 1.3 females. You might have come across this, which is totally wrong. How can there be 1.2 males? Because they are not using mode as a central tendency. They are using median as a central tendency, which is wrong. Second, if your data is ordinal, ordinal means what? Rank. Then compulsory you have to go for median and you have to go for interquartile range. This means if your data is say size of the product, low, low, medium, medium, low, medium, then say high, and so on. If such kind of data is there, you have to go for median only, and then you have to go for interquartile range, compulsory. If your data is numeric, if your data is numbers, then you have to be very careful. If your data is numeric, you have to ask the question. You have to ask the question: is the data numeric, that is normal, or it is not normal? Means not normal means what? It is skewed, positively skewed or negatively skewed. So even if your data is numeric, the next question you need to ask: is it normal? If it is not normal, then again you have to go for median and interquartile range. And if it is normal, then only we can go for mean and standard deviation. Unfortunately, even in research papers, even some of the PhD guides, in some of the industry reports, they are maximum times they are using mean and standard deviation. It is not their fault because what they have in their mind, in the books it is written mean is the ideal average, standard deviation is the ideal dispersion. That has fitted in their mind. And so for all kind of level of measurement, for all kind of data, they go for mean and standard deviation, and that is totally wrong. Now this will give you an idea when to use which type of measure. Something new? I know majority of you might be aware of this, but I thought we need to clarify this as a sound fundamental foundation for statistics. So if I sum up, I will always give you as a table and also as a diagram, because psychology says diagrams are easily remembered by learners. Pictures are easily remembered by learners. So I'll be giving a flow chart also. So what is a flow chart? If your level of measurement is categorical and if it is nominal, then compulsory you have to go for mode, but you cannot use any dispersion. If it is ordinal, then compulsory you have to go for median and you have to go for interquartile range. If your data is numeric, ask a question: is it skewed or it is not skewed? If it is skewed, again median and interquartile range, and if it is normal, matlab not skewed, then only we can go for mean and standard deviation. Kanchanji, it is very simple. How to know that the data is normal? You check the level. That means if your data is, say, age, which is given in years, 27 years, 32 years, 40 years, 15 years, then it is very simple. This is numeric. If your data is, say, color, color of the cloth, say white, black, blue, black, and so on, then this is nominal. If I ask you your favorite actor, if I ask you the favorite actor, say it is Amitabh, say it is Rajnikant, okay, say it is someone else. Now this is also nothing else but a nominal. Okay, this is a good question, yeah, Rupinder ji. How to know that it is normal or not normal? There are tests for it. That will teach you when we go further. There is a Shapiro-Wilk test for it. There is an Anderson test also for it. There are many tests. That is a QQ plot that we can go for. You can go for histogram. You can go for box plot and so on to check whether the data is normal or not. I hope Kanchanji, your question is clear. I have answered your question. How to know the data is normal? You have to check the level of measurement. That means if a variable is given to you, check, is it only classification? If yes, then it is nominal. If you can order it, then we can go further. Rupender ji, your question will answer it later on, but I've just given an idea that this is how we can check whether it is normal or not. Okay. Again, you will be astonished by the charts. Last 13 minutes are there. This will also help you to take a right decision. Which is this chart? Very funny. You all know it is a pie chart. This is, again, you all know it is a bar chart. Sridevi ji, hai na? Bar chart? Okay. This is multiple bar chart. This is divided bar chart, or you can say stacked bar chart. Stack. एक के ऊपर एक है, so it is called stack. Which is this? Anyone can know what is this? Which is this chart? Let me check. How many of you are knowing it? Which is this chart? Okay, Dr. Angna, Dr. Pauline, good. It is a box plot. Unfortunately, in very few of the papers or in very few of the, I would say, even the thesis or the reports include box plot. And actually, wow, Dr. Lata Ji, Ilonga, forgive me if I pronounce it wrongly, but yeah, that's good. So that you are knowing it, this is a box plot. We'll go into detail about that. This you all know it is a histogram, this is a scatter plot, this is a line chart. So you all know about the chart. But if I ask you a question, when to use pie chart, when to use histogram, when to use a bar chart, you will see it is a stupid question. Why? First of all, start with pie chart. Normally, this is how the charts are drawn. 4 5 pie charts because it is very colorful and attractive. So you'll start with some of the pie charts. After 3 4 5 charts of pie chart, you'll say it's bahut ho gaya. It's enough. Then you'll go with the bar chart. After 2 2 3 bar charts, then you'll find out some other charts for it, whether to draw histogram, line chart, box plot, scatter plot, and so on. So this is the wrong way of deciding. There is a specific type of data for which you have to use a pie chart. There is a specific type of data where you have to use a histogram and so on. Now let me go into deep into that. But before that, as some of you know box plot, let me explain to the others also. Box plot is a very important 5-point summary chart. In one chart, in one plot, you get 5 points over here as a summary. Which are they? It gives you Q1, it gives you Q3, it gives you median, it gives you outliers, that is minimum value, it gives you maximum value also. 5 points are given. Let me explain it again. What it is done, this is a box, and these are its whiskers. Whisker matlab mooche. That is why the whole name is box whisker plot, but very famously called as a box plot only. But the whole name is box whisker plot because this box has a whisker. Whisker matlab mooche. What does the box signifies? Box signifies the lower part is Q1, upper part is Q3. Now you know Q1, Q3. If I draw it over here, Q1, Q2, Q3. Each are 25%. Exactly they are divided, 4 parts. So this is Q1, Q3. The center line is median. So we are getting already 3 features from it. This is the lower limit. It is called minimum, but actually it is a lower limit. What is lower limit? It is Q1 minus 1.5 interquartile range. What is interquartile range? This is Q1, this is Q3. This distance is called interquartile range. That is Q3 minus Q1. So Q1 minus 1.5 interquartile range is lower limit, which is called minimum. And same way, upper limit, which is called maximum. It is Q3 plus 1.5 interquartile range. Now, if a point lies somewhere outside over here or over here, then they are called outliers. What are outliers? Suppose you are typing some data. Say, for example, weight of a person. Then say you are measuring weight of a person 70. You are typing it out 70, 80, 65, 60, 54, 110, and so on. One of the observation by mistake, you typed it as 1100. Or some of the observations you typed it as 1.4 by mistake. Then compared to our other data, this is very high, which is abnormal. Normally, weight cannot be for an adult, it can never be 1100 kg or it can never be 5.4 kg. So, if a point lie beyond this maximum value, then it is called outlier. If it lies below this level, then also it is called an outlier. If you find this outlier, that means either there is an abnormal observation or there is some typing error for it. So one box plot gives you all this point in one chart. In one chart, you get all this kind of observation. This is called box plot. Sure. Now for the last 6 minutes, come on. When to use which chart? This is again an important slide for you. So three things were very important, which I'll discuss it, summarize it at a later stage. Suppose you have only one variable to plot the chart for. You want to plot only chart for one variable. Say it can be height, it may be income, it may be gender, it may be say income group or age group, any, but I want to plot for only one. Then what are the level of measurements? Mainly here it can be scale or it can be category. So we are not going into detail for the graph for nominal and ordinal and all. It is all categorical. So if your variable is one variable, it is scale. Compulsory you have to go for histogram or box plot only. These are only allowed. These are only correct graph for your scale data. One scale data. If your data is categorical, gender, income group, feedback, like a scale, then compulsory you have to go for bar chart or a pie chart. If you want to draw the chart for two variables together, say for example, I want to draw the chart for height and weight. I want to draw the chart for gender and income, two variables. So if you want to draw the chart for two variables together and both are scale, like height, weight, or income, expenses, or import, export. So there are two scale variables, two numeric variables. Scale means numeric. Okay, if there are two numeric variables, then compulsory you have to go for a scatter plot. If one is categorical, other is scale, like gender is a categorical, income is a scale. If I want to draw the graph of one categorical, one scale, I have to go for side by side box plot. Side by side box plot, which will teach you later on how to draw. How to draw this is not important. That software will do. But to understand the concept, when to use which chart, when to use which summary statistics, that we as a human have to decide. Okay. If it is one categorical, one scale, okay, it is same side by side. If both are categorical, that means gender and say job position, whether junior clerk, senior clerk, manager, senior manager, vice president, president, that is a job position. So gender wise job position. Then we have to go for side by side box plot or stack side by side. That is called multiple bar chart or stack bar chart. This is how the graph needs to be drawn. You know something new? Okay, so now you have to understand when to use which type of chart in your own research, in your with your own data. I hope it is clear. Sure. Fast. Movie genre, action, thriller, horror, romance, and so on. If I want to draw the chart for this movie genre, which graph I should draw, which chart I should draw? Okay, Rupinder ji, pie chart, that's great. Anyone else? Fast, last 1 minute is left. We want to summarize the whole thing. Okay, Kanchan ji, pie chart. How about others? Hungry? Mondos, pie, fine, that's good. Now that is the speed. Good, pie chart. Yeah, good, Pushpaji. Both bar or pie, both anyone can be used. That's great, Dr. Natarajan. That's good. So this means now you are realizing it. Movie genre is a categorical. And for categorical, you can use either pie or bar chart. Next, restaurant feedback. Bad, neutral, good. Which type of variable? It is a categorical variable. And it is only one. That is a restaurant feedback. And so again, you can draw pie or bar chart. That's great. Box office collection of the movie released in 2023. So box office collection. How much movie has collected? Which is the variable? It is a scale or numeric variable. So what should be the chart? Wow, I got the answer. It is scale. That's okay. Which type of chart has to be used when there is only one variable and that is scale? Okay, Jenny, perfect. Histogram. Now that's good. Histogram. Kamli Sri, Mandapati, Dr. Pauline, Dr. Angana. Yeah, that is what you expect. Okay, Jyotish. Now the histogram, Subhashri, that's good. Okay, baby Jyotish, that's good. See, because it is there is only one variable, which is that there is only one variable which is scale. So either histogram or a box plot needs to be. Import versus export. Come on fast, last. Import versus export. There are two variables now. One is import, one is export. Both are scale, both are numeric. Which chart? No, Janny. Which chart? No more on those. Scatter plot. Yeah, now it's fine. That's good. That's perfect. So when both are numeric, both are scale, you have to go for a scatter plot. Here, I'm making it fast. Virus variant versus number of patients. During Corona, we were seeing variant 1, variant 2, virus variant 3. The variants are nothing else but category. Number of patients were nothing else but numeric or scale. So if one is categorical, other is numeric or scale, we have to go for side by side box plot. Side by side box plot. Perfect. Okay, that's great. If one is gender and favorite color, same. One is gender. Gender is which type of variable? Categorical. Favorite color, categorical. Both are categorical. If both are categorical, then side by side, that is multiple bar chart or stacked bar chart has to be. Okay, that's it. That's good. Perfect, Jenny. Mandapati, yeah, you're right. Subhashri, that's great. Wow, wonderful. So with this, thank you all. So we have time ka pata hi nahi chala. It's 1.5 hours that we were together. And I'm sure, as I said and as I promised you before, this 1.5 hours would be very, very, very important for you to clear your fundamental concept. Have I fulfilled the promise that I gave? Same way, the next 5 days that we are going to do will add a lot of value to you in terms of data analysis and the concept clearing. Okay, so that's great. Perfect. Thanks for the wonderful feedback. And same way, I'm assuring you that this next 5 days or so, it will be very, very game changing for you. With this, we end the session. Ma'am, it's over to you.
Yes, sir. Yes, sir. Yes, we will be providing the feedback. Sir, PPT, please share to me with my WhatsApp, sir.
Yeah, we will. So that is one good thing, that once this is done, you will get the presentation also with you.
Yes, sir.
So Sai Leela ma'am has requested that the participant should get the resource also. So the advantage is that you can refer it at any moment of time wherever you need it. Otherwise, what is happening that once the workshop is done, it will be very difficult to recollect.
Yes, sir.
The slides will be with you forever, and then you can refer it as and when you require it. Okay?
Okay, sir.
Done.
Okay, sir. Thank you so much, sir. We extend our deepest gratitude to our resource person for his exceptional expertise and unwavering dedication in guiding us through the fundamental principles of statistics and its practical applications. His mastery in elucidating complex statistical concepts, coupled with their adaptness in handling graphical presentations, has equipped us with invaluable skills to analyze and interpret data effectively. Furthermore, SAR's comprehensive understanding of both quantitative and qualitative data has broadened our analytical capabilities, enabling us to make informed decisions with confidence. We are truly fortunate to have benefited from SAR's expertise and mentorship, and its impact will continue to resonate in our academic and professional endeavors. We express our sincere gratitude for you, sir, for your invaluable contributions to our growth and development. Thank you so much for the wonderful session, sir. Thank you so much.
Thank you all and a wonderful dinner. Bye.
The feedbacks are very nice, sir. Very good feedbacks in the chat box. Thank you so much for the lively session. Thank you, sir.
Okay, bye. Bye.
Yes. So for the information of the participants, this program is going to be finished on 24/4/2024. Kindly make a note of it. It will be ending on 24/4/2024. We will be having 8 working day classes. Saturday, Sunday we have no class on Saturday, Sunday. Excluding Saturday, Sunday, we have 8 working classes here. So you kindly check the browser for the information. So a plan according to you to attend all the sessions. Thank you very much for your patience. See you